Who are we? Why are we here and what do we do, you may wonder? We are a couple. We are a couple of kooky nature nerds trying to do our part to make a difference in this fastly evolving world. As we are among the privileged humans who get to walk this planet, and as humans are arguably the most privileged of all the species, Spencer and I have turned our lives' focus and passion to much smaller and often misunderstood creatures that are in need of a little extra help these days. These creatures we speak of go by the Latin name Apis mellifera, also known as the honeybee. The honeybee plays an indispensable role in the survival of a large portion of all the plant life on Earth and for the survival of the creatures that eat the fruits of her soil, including us lucky humans. If we all work together, we can help preserve the ecosystem for honeybees and subsequently for future generations. My name is Mariah McDonald. This is my partner in love, life, and business, Spencer Jones. We own and operate a honeybee rescue and education company called Swarm Entender, and we are here today to share with you a little part of the magic world of honeybees.
Thank you. So why do we call it the magic world of honeybees? Aside from their ability to fly with such a small wing to body mass ratio, often considered by science as an anomaly in early studies or a miracle, so to speak, there are thousands of years of lore from all over the world regarding honeybees as a sign of magic. Several deities are associated with bees and honey: Aphrodite, Ra, and Pan, just to name a few. Pan, if you will.
And Vishnu, I think, as well.
Vishnu as well. In this slide of an Egyptian tomb, an ancient hieroglyph and carving, you can see that there's much reverence for the bees, and the pharaohs from ancient Egypt often used the honey bee and honey itself as a symbol of royalty for up to 3,000 years.
This other image we have here is an example of some modern day magic. This picture is taken in Tibet, and this man is about 300 feet up on a rope ladder, holding with one stick a basket and another stick a slicing device that actually harvests the honey from the cliff sides. This is a tradition that's been happening for thousands of years in Tibet and Nepal. And this species of honeybee is actually the largest known species of honeybee in the world. And another sort of little tricky magic of this specific honey and these bees is they forage on a specific type of plant called a rhododendron. And it's actually a specific type of rhododendron that has a psychotropic constituent in the nectar that the honeybees harvest. So the honey that these people are harvesting is actually psychedelic honey.
So that specific rope ladder that they were using hanging cliffside in Nepal and Tibet is actually a long used tool of the trade. This cave painting from Spain is dated anywhere between 8,000 to 15,000 years old, depending on who you ask, and depicts a woman or a man, kind of an androgynous figure, a choose your gender figure, climbing this rope ladder to harvest exactly what we saw in the previous slide, a comb of honeycomb and with honeybees flying all around her. I like to say her because you kind of have to be a feminist to be a beekeeper.
And we'll get into that further. The other image we have up here is an ancient coin from Greece, and the honeybee was also regarded as a token of magic in Greece and was often associated with the goddess Aphrodite. And Aphrodite's priestesses who worshipped her and held temple to her were actually called honeybees. We're sort of making reference to some of this historical reverence that humans and honeybees have had for each other for thousands of years. Moving from ancient history into a little bit more modern science of honeybees, we're going to now start to talk about the sort of culture and systems within a beehive, the different types of bees within the hive, what their roles and functions are, and how we interface with them. And we'll start with the three types of bees that you'll find in a honeybee colony. We have a worker, a drone, and a queen bee. We like to start by talking about the worker bee because she makes up 97 to 99% of a colony throughout the year, which is reference back to why Spencer said you probably need to be a feminist to be a beekeeper, because not only is the future feminist, future is female in the bee world, it's always been for these bees. The workers have a range of tasks. They're the smallest honeybee. Has anyone seen a bee on a flower? That is a female forager honeybee. So that's a worker, and those are all ladies.
As we'll come to find, there's a bunch of different castes or qualifiers to the worker bee. The drone in the middle there, on the other hand, has one job. We'll find out what that one job is in the future, but to accomplish this job, he's got these really giant eyes. He's a little bit larger in size. These photographs are not to scale. Don't be afraid. There's not a giant drone the size of Mariah's hand flying through the air. And they've got a rounded fuzzy bum.
And the last of the 3 bees in our colony is the queen bee, Her Majesty. She is the only queen in a colony at any given time, and she's responsible for the birth of every single bee that comes from that colony.
Here's another image. This is more to scale. It's a late 1800s scientific illustration of the 3 bees. Again, you can see the smallest, the worker bee, making up that 97 to 99% of the population. The queen, there's only one queen ever in the hive. She stays front and center there. She's kind of got that longer turnip-shaped body. And then the drone, kind of mid-range there with his giant eyes and rounded behind.
And part of why we make reference to this rounded behind is you can see in this image also that the worker bee has a stinger, and her stinger is actually her modified reproductive organ, because the queen is the only one who needs to reproduce. So only the female worker bees and the queen have a stinger. That reproductive modification still is linked to all of her intestines. So if a honeybee stings, she has a barbed stinger and she perishes after she stings. So they're not inherently aggressive. They don't want to sting us, because if they sting us, they die. So that we're also trying to kind of realign and associate. Clearly we love honeybees, so you guys can too. They're actually really sweet and cute. Moving into the honeybee life cycle, this is an image we took in our apiary the other day. If you look towards the top center and kind of in the middle center, you can see a tiny little, what looks like a grain of rice, and that is an egg. And that is what we really want to see in our colonies, because that means that the colony is queen right. And queen right means that we have a virile queen who is laying eggs, and that means the colony will continue to go on. You can see from that egg that it then turns into a larva. The larva will then continue its gestation, and Spence will talk about that.
Yeah, so the egg gets laid, it stays an egg about 3 days. The queen is responsible for laying all of the eggs in the hive. After that 3 days, the egg kind of tips over inside of the cell and hatches into a larva. The larva is immediately fed a substance called royal jelly. You can see in the photograph, there are kind of larvae bathing in this white substance. Royal jelly is kind of a health craze as well, filled with tons of really vital proteins for the growth of the larva. That larva then grows over the course of days depending on what type of bee it's going to become. For a female worker bee, it's 21 days, for drone 24, and for the queen, only 16 days, even though she is the largest of all of the bees in the hive.
And she gets a diet of pure royal jelly, which is part of why she gestates so quickly. And also we sort of like to make an analogy as each bee is an individual, but without their colony, they're not complete. So we sometimes like to use the analogy of a colony of bees being like the human body, and that queen bee being the beating heart. So she is indispensable for that survival of the colony.
This is a video and an image of a swarm. And a swarm is essentially a birthing process of the hive. It's a natural process that we love to encourage. The swarm is essentially a cell split. What happens is the colony gets really healthy in the spring and summer months. It starts to fill out wherever they're living, be that in a hive like we have, man-made, or in the side of a house or a log, wherever they're living. They will outgrow their environment, create a new queen or a series of new queens, and then she takes half of the bees and flies into the air, gathering on a local tree branch or somewhere nearby in this cluster that you can see. This one was especially large. We named her Big Beetha because she was one of the largest swarms that we caught this season. We were pretty proud.
After we had gone, so when a swarm is looking for a new home, they settle and they send out forager bees to try to find a new home. And if we're lucky enough to get into that space, we can actually catch that swarm into a box. So we had a cardboard box in the back of the car, popped this swarm into that cardboard box. And then I was able to actually dump, and we got a great slow motion video of a huge mass of bees dumping into this box, which they've colonized. They're now 5 boxes tall, one of our most productive, healthy, happy girls. That moves us into speaking about the lovely worker bee. And that's the lady that makes up 97 to 99% of the colony at any given time. And we've created 2 separate images, compilations of images to describe the life cycle of this worker bee, because she spends the first half of her life inside the colony completely as a nurse bee. And that nurse bee is responsible for a huge number of things, including making honey. She makes the wax. She makes that royal jelly that we were discussing. They secrete royal jelly from a gland in their neck, and that's what the queen eats, and every egg gets a little bit of that throughout their life. They're responsible for feeding and cleaning the queen. There's a group of ladies that are called the royal court, and they stay within antenna distance of the queen to make sure that she has all of her needs met. They're also responsible for feeding the eggs and larvae. They keep the inside of the colony at a consistent 95 degrees, and every single thing inside that honeybee colony is antiseptic, antimicrobial, antiviral, antifungal, antibacterial, because they're in such close quarters that if any parasite came in, it would knock them out, which is part of why honey is such incredible medicine, and all of the bee products that we consume as humans are great for us because they have all of these microbes that are great for our systems.
And you can see in this image, they've started burying their faces in honeycomb. They're either feeding by regurgitating, feeding honey to some of the larvae, or actually packing those cells full of pollen, making that substance called bee bread that Mariah was mentioning. That's those colorful cells that are all throughout the photograph. And it's actually a fermented pollen that they use as a nutritive for both themselves, the queen, and the babies.
It's their protein source. It's their source of fat and protein. So the honey they use as their source of carbohydrates and sugars, and the bee bread they use for their proteins. Does anybody know how honeybees make honey?
This is my favorite part.
It's very, very exciting to us. So as the bees fly out, we'll talk about how they collect that nectar. They make honey from nectar. And what they do once they have their honey stomach full of nectar is they fly back into the colony and they find one of their sisters willing and ready with her open mouth, and they regurgitate that nectar into the mouth of their sister. And that sister then regurgitates again into the mouth of another sister up to 30 times between one another, all the while mixing that nectar with some of their stomach enzymes, creating that antimicrobial properties like we were discussing, as well as creating these little air bubbles. And as those air bubbles pop, that liquid, because the nectar is about 70% moisture and honey is about 17%, which is part of why it lasts forever. So what they're doing is evaporating the moisture with their little saliva bubbles. And once it's gotten to that perfect antimicrobial phase, and as well as the perfect 17% moisture, they then regurgitate it into a cell. Once that cell is full, they cap it up, and it's just kind of like putting a jar on your preserves to make it through the winter. So delicious, huh?
Sometimes changes people's opinion. So we talked about all of the jobs that bees have inside the hive under the umbrella of the nurse bee. The very final job that they have is a guard bee. The guard stays at the front of the hive. They mostly are monitoring all of their sisters coming and going, as well as making sure that no intruders come in. If a wasp or a yellow jacket, or even things as large as like a mouse or a shrew tries to come into the hive, they'll attack as a unit, as well as try to just kind of shuffle people along. If there are bees that are coming from another hive, maybe coming through to rob, they'll smell the wax glands that they have on the side of their body and be able to ID them, kind of like a bouncer, and say, no, you're not part of our team, move on. And that is the final job they do before they begin to take flight. So all those bees that we've seen out on flowers are known as forager bees. And the foragers are in the last couple weeks of their life, typically in the spring and summer months, and they're working 24 hours a day, either out gathering nectar and pollen from flowers or inside the hive coming back to transfer that nectar and pollen into the nurse bees.
And there's actually a really interesting morphological shift that happens in the body of the honeybee as they move from a nurse bee into a forager bee. The nurse bees are inside all the time, so they get really developed crawling muscles. The forager bees are flying outside of the colony, so they actually have to learn to grow their wing muscles. And so that's actually a genetic or a morphological shift that happens in these honeybees during their life cycle. Once they're making that transition from nurse bee to forager bee, they'll actually learn their flight path and train those muscles by flying a foot away from the hive, and then 3 feet, and then 20 feet. And then eventually they can actually have a 5-mile flight radius in any direction. So honeybees that we see on the trees out here could be living 5 miles away, coming to get this luscious bayside nectar to make their beautiful honey and bee bread. We see a couple images here. If you look at the picture of the yellow flower, this is a honeybee doing her job of pollination. And so honeybees have really complex communication systems within them, their own colony. They communicate primarily through frequency and pheromone. And they also have that type of communication with flowers. So the color of a flower is a frequency, and the flower also emits a frequency whether or not it has been pollinated. So if a flower hasn't been pollinated, the honeybees will know because they have these little sensors on their sweet little toes. When they land on a flower, it'll have a frequency, and if it's been pollinated, you'll see them just immediately move to the next. And if it hasn't, they'll shove their sweet faces into the flower like we can see in the sage flower, that yellow flower. What she's doing here is she's extending her long tongue that's called a proboscis, and it's sort of like a straw. And that straw reaches down into the base of this flower. The flower has made nectar specifically for the purpose of giving its pollinator a treat. It's sort of like an alluring treat for the pollinator. That honeybee slurps up that nectar, puts it into a stomach that she has called her honey stomach, which is separate from her eating stomach. And as she's doing that, the male part of the flower, called the stamen, puts pollen all over the back of this honeybee. You can see in some of the images we've seen before and here that the honeybees are covered in hair. Even their eyeballs have hair on them. So as that pollen, which looks like tiny little microscopic Velcro balls, lands on those honeybees, they'll lick their arms and put it back on, as you can see in the image with the white background, that orange pollen sac that we kind of fondly call saddlebags. They'll collect that pollen in their saddlebags, but they won't collect all of it. So as they're flying, each flight that a honeybee takes from her colony, she will pollinate up to 500 flowers. And she'll do that up to 3 times a day. So if we have a colony of bees that's, let's say, 100,000 bees, which is kind of an average size colony, 50% of which are forager bees, each of those bees are pollinating 1,500 flowers a day. If you can imagine that, these girls are extremely efficient at what they do. They're incredibly efficient pollinators. 1 in 3 bites of food we take, we can say thanks to the Google team as well, the food team, has to do with these honeybees. So Google food team, honeybees, great combination, great relationship there.
But all of that wouldn't be anything with just one bee going to one flower source or one water source. They have to be able to communicate. And even though they're communicating with the flowers and communicating through vibration and pheromone, they need to create very detailed maps to each other of how to get to this forage, how to get to the nature. And so they come back to the hive. They do something called a waggle dance. A waggle dance is a very intricate communication system. It's kind of like bee twerking. They come back to the hive. They orient their shadow always at 30 degrees to the sun, and they walk in a figure 8. And while they're walking in a figure 8, they shake and they make all of these little vibrations from 10 hertz to 1,000 hertz. And those are intricate communications of just over there, past the tree, take a left, there's a water source. If you go a mile over this way and then you turn around this U-turn, you'll find a field of flowers. And they were able to study this with a bunch of German scientists who devoted about 10 years of their life to studying bees at the hive, what they were dancing about, and where they were going. It was pretty fascinating.
So they're a pretty intricate system, and their communication is kind of like the internet. Next up is our sweet, sweet drone. As we discussed him before, and remember his big bulbous eyes?
He uses those eyes for one specific task. He lives about 3 months, or he could live 1 day. And if he lives 1 day, it's because he got lucky. He goes outside of the hive every day around the hottest time. 1 to 3 is how we're seeing our hives actively have their drones come out lately. He comes out and he uses those big eyes with all of his drone buddies to look for the smell of a virgin queen. And yes, I said look for a smell because they can see vapor trails. They can see the particulate that makes up scent.
So they see smell.
So
which
they
to
can
me,
see
every
3D
single
smell
time.
in color. And they're
crazy.
doing that, looking to get lucky, looking to the sky for a virgin queen that's flying up. And then 12 to 20 drones will fly up, mount the queen, and then deposit their genetic material. And then they lean back, their reproductive organ breaks off, and they fall to the ground dead, saying, "It was worth it."
So as Spencer was saying, the drones can live up to 3 months, but if they get the opportunity for their day in the sun, they can live a day. The honeybee, the worker bee, lives an average of 52 days. And then moving into our next lovely lady is the queen. And the queen can live 3 to 5 years. So if you think about that ratio, 52 days, maybe 3 months, 3 to 5 years.
It'd kind of be like your mom living to be 40,000 years old.
So this 40,000-year-old mother is the only one in the colony, and she's responsible for laying every single egg that ever turns into a bee in that colony. And as I said, 100,000 is kind of an average size. We can have a colony, a small colony that's about 15,000, ranging up to a very large colony that's 250,000. And every single one of those babies comes from one queen. She is the only one in the colony. We have a couple different images here because we have a fun game like Where's Waldo? Find the Queen. We take pictures of frames of honeybees with the queen on it, and then there's the task of trying to figure out how to train your eye to identify. A couple ways to identify is, as Spencer had mentioned before, she has that longer turnip-shaped body. She also has kind of a bald head. She looks a bit like a friar from a monastery. And she has shorter wings as well because she only flies that one time for that maiden voyage, leaves as a virgin queen or virgin princess, comes back as a mated queen. She then has all of that genetic material from the drones on one side of her body and all of the eggs that she'll ever lay in her life in a sac in the other side of her body. She then, once she goes back into the colony, will start to lay eggs, and she will lay between 500 and 3,000 eggs every day for her entire life. So when ladies are like, "I'm the queen bee," I'm like, "You go, girl, you got that job. I'll be a forager."
I'll be a drone. So it's all right with me.
So that's the main task of the queen. She doesn't feed herself. She doesn't clean herself. She has that royal court that takes care of her, keeps her within that antenna distance. And what she's doing is finding a cleaned out cell, turning around, depositing her abdomen, and putting one egg at the bottom of each cell. Every time she lays an egg, she decides if it's going to be a fertilized egg or an unfertilized egg. The fertilized egg becomes the female worker bees. The unfertilized egg become the drones. So they're actually genetically identical to their mother. Something fascinating about the genetic flushes of honeybees is because she has mated with those 12 to 20 drones, we'll actually see different flushes of different genetics from each drone throughout the life cycle of this queen bee.
These are a couple images of frames and hives. We keep a Langstroth hive. There are many different styles of hive bodies, but when they're human fabricated, the Langstroth hive is one of the most common and has been around for over 100 years. It's kind of like a glorified filing cabinet. So it has the main base, as you can see here, and then inside there are 8 to 10 frames that can pull out vertically. Some of these images show this exact thing right here. And so the bees are busy making all of their honeycomb inside of these frames. It gives them kind of a representation of what they might do naturally. They always draw comb from the top down, and they'll draw it with inside this rectangle given the space.
And part of why we've pulled up these images today is because we were talking about the different individual bees, but truly none of those bees could survive without the synergistic relationship of all of them together. And what's kind of hot right now in human community and culture, as well as the honeybees, is this concept of hive mind, of everyone with this intuitive communication, with this frequency and pheromone communication. We all, if we work together, can accomplish so much more than us as individuals, including helping to save the bees and including what you all are doing here. Each and every one of you has such an incredible, unique, bright mind and these abilities and capacities to do all of these different things. But if we're an island, we can't accomplish as much as we can if we're all working together. So I think the honeybees are a really graceful and a really elegant example of how we all need each other to survive. So we have a couple images, like Spencer was saying, of colonies. You can see what they do and build. The image of the bee with her saddlebags and her bum up is an example of one of their communication tactics. What she's doing is she's just clearly found a new amazing food source, as you can tell by that pollen sac. And she's landed on the front of her colony. She has her bum up in the air, and her stripes are actually scales. They sit on top of each other, and they have 8 glands on 4 on each side of their body, and they release a pheromone. And so she's communicating to everyone else where the food source is. So again, another example of her going out, doing this reconnaissance work, and then coming back and them all working together, providing a situation where everyone can survive and thrive.
And here's some more images kind of drawing that corollary between what the bees do, what the hive mind is, and where its origins come from, but also what we can accomplish. We wouldn't be able to accomplish space travel on our own. We also wouldn't become a giant 40-foot tower of people.
Can't do that with one human. We need to be all together.
Both ends of the spectrum. But together, that's how we can accomplish it, when we're working selflessly, working together and trying to find our way.
And the image of the frame there is beautiful fresh wax, and that is another example of how bees and humans are really similar. They're actually one of the only species that plans ahead with their food source. They make all of the food that they eat, and part of why they make so much honey is because come wintertime there aren't flowers to forage, so they make all of the honey they need for throughout the winter. So it's another example of their intelligence and working together to be able to survive as a whole.
This is a video that is displaying even more of that intelligence and more of that working together. They are in swarm cluster form, and they're throwing their bodies in this wave-like motion to look
kind of
like
if
a
you were
much
at the World
larger
Cup.
identity, much larger animal. It's kind of like, Mariah was saying, at the World Cup when everybody gets up and does the wave. They're doing it as a defense tactic to make everything look like they're this one big object. Also, it's just kind of fascinating to watch.
Yeah, we've wanted to use it as a reference, and also it's really cool. Moving into a little bit more of how they're in trouble. Honeybees are absolutely in trouble. That's part of why we're here speaking to you today. That's part of why we've dedicated our passion and business to trying to help the honeybees. In 2006, there was a term coined called colony collapse disorder. National average last year was a 70% loss in honeybees. We lost 70% of our colonies over the winter. We're getting back up by catching swarms, but the issue is real. And again, as we had mentioned before, 1 in 3 bites of our food comes from the honeybee. So outside of them being ecologically necessary to continue this diversity, we need them as humans to survive. So we have a couple images up here. There are a huge number of theories about why the honeybees are dying. I don't think one is right. We kind of have a running joke that if you ask 2 beekeepers one question, you'll get 5 answers. Everybody's expert on these things, but the truth is nobody totally knows why, and I think it's a combination of all of the things. The image you see with that vast, beautiful orchard is an almond orchard, and this is an example of monocropping. It's beautiful, and it's an incredible food source for honeybees for 2 weeks to a month, but they need longer than a month to get enough nectar and pollen to be able to last through the winter. So after this bloom is done, it's a food desert. There's nothing for them to eat, which is part of why so many people are bringing in pollinators. And there's a huge issue with that because a lot of the pollinators are dying. The image in the middle is power plants, cell phones. We were just talking about how Erica Badu is helping people understand that cell phones, power plants, the frequencies that are in the air are actually disrupting their flight path because they're frequency-based creatures. So they learn their geolocation through a frequency, and then if a cell phone call comes through or there's a Wi-Fi frequency that kind of disrupts their frequency, they can't find their way home. And this other image is of urban sprawl, which is another issue that's happening for honeybees. We all need a place to live. We live in a city. We live in a home in a city. I'm really grateful for it. And there are little things we can do, like planting a planter box in our front yard. If you live in an apartment, hang it over the balcony if you have one, or have it outside your window. It really makes a difference. Because the honeybees with this urban sprawl have to fly further and further distances to try to receive enough forage to create the honey, and they get too tired when they're on their way home and they just perish on their way back.
These are a few more images of things that are contributing to colony collapse. It really is a perfect storm. Those 3 other images are just 3 factors of many. But one of the one of the sources that is really a hot topic within beekeeping are the Varroa mite. And the Varroa mite is this tiny little bug that's a parasite that comes in and actually creates degenerative diseases, wing diseases on the new bees that are born, so that way they cannot fly, they can't leave for forage and gather food. And it really quickly destroys the colony from the inside out. One of the reasons why the Varroa mite is coming into play so strongly now is that we've gotten into so much genetic manipulation within the bees. We want them kind and we want them to make lots of honey for us. But when they're really kind and really good at making honey, their focuses aren't on guarding, their focuses aren't on self-defense. Oftentimes our unseen hand in beekeeping limits their ability to develop these tactics, or our genetic manipulation stifles their growth.
As an example to illustrate that, have you guys heard of the Africanized honeybee? It's kind of a scary thing that's happening. Africanized honeybees don't have mites. They don't die of mites. They don't die of the small hive beetle. They also don't experience wax moths. They're more aggressive. They're more dangerous for humans, but they also have an ability to survive. So that's one of the things that we're illustrating, is that by genetically breeding honeybees to be really gentle and docile, we're actually taking away their ability to have an immunity against these pests coming in. Another part of their immune system is that, just the same with humans, if we continuously take antibiotics, our immune system starts to get weaker and weaker, and the pests and the bacteria that's coming into us is actually getting stronger and stronger. So by treating bees and giving antibiotics consistently, it just weakens the immunity of the honeybees, and it's strengthening those parasites, the mites, the small hive beetle, and the wax moth. We don't have a great solution to this. I'm not trying to say that treatment beekeeping or treatment-free beekeeping is the way. I think everybody is doing our best. We're just kind of trying to illustrate some of the things that are happening. Another huge thing absolutely has to do with pesticides. There's not an insecticide or a pesticide that won't affect an insect like a bee. Whether or not it's quote unquote bee safe, they just really do affect the neuropathy. What happens a lot is it actually rewires the bee's brain synapses, and when they get back to the colony, they just can't perform their function. The image that we have is kind of dismal. It shows what happens when you can actually see the dead bees. Another huge thing that's happening is called absconding. And a number of the hives that we lost this last winter were just gone. They took the honey sometimes, they left the honey sometimes, but they were absolutely gone. And this is one of those sort of mind-bending anomalies of what's going on. We don't really know, and we can't even study them if they're not there. So
yeah, it's a huge question mark in the industry currently. There's so many factors leading into it, but there's no answer because there's nothing left to study.
But fear not, there is hope. We are here not just to talk about how there's trouble. We're here because we want to spread the fact that there is hope and there are things that you can do. Here are some images of things that you can do.
We can support each other and support beekeeping as a whole. Purchasing raw and local honey is a great way to support beekeepers. If you don't have the time to become a beekeeper, hopefully everybody does. It would be great. But if you don't, you can support your local beekeeper. Buying and eating raw and local honey is also great. So many health benefits from the homeopathic quality of consuming the pollens and other allergens that might be affecting you seasonally by eating that raw. Always raw, and local is usually best. When we heat treat or pasteurize honey, it takes away most of the nutritive value. So raw is key.
So when we're helping people to understand, like, hey, should I buy local or should I buy raw, or how should I do this? Should I get it at Costco? Number one, make sure it's raw. If you can, make sure it's raw and local. If you can, even better, go meet your beekeeper. Go check out what the bees are foraging. It's really, really incredible. And like we said before, the bees have no interest in us unless we're a flower. So I'll get right next to a bee that's foraging and just give her a little pet on the back. She's kind of like, doing my job, leave me alone. Which leads us into our next image. Plant flowers. It's such a beautiful, luscious way to help, and it really does help. We brought some seed packets today from one of our apiaries. I'm an herbalist also, so we plant lots of medicinal flowers around our apiary so the honeybees can go and visit the medicinal flowers, actually receive some of the benefits of that medicinal plant, make medicinal honey through that, and then we can harvest the plants, make medicine from them, and we've harvested some seeds. So if you have a yard, if you know people with a yard, if you're into seed bombing and just want to throw it on a patch of dirt and see if it grows, you're more than welcome there by the front door. When you come in, please take a packet.
Also, another thing you can do is education. kind of like what we're doing. Even if you learn just one fact today, telling that fact to somebody else raises the awareness of the necessity to care for this species. Just telling others and getting that cipher going of excitement about the possibility that we can do something, that we all can do something.
And regaining that sweetness, that connection. We wanted to start with the ancient connection that humans have had with honeybees to sort of help everyone realize and to re-illustrate that they're actually really sweet. They're actually our good friends. Another thing that's helpful, if you don't enjoy honey or can't plant flowers, is you can donate. Funding the change is making a change. If you can donate to local pollinators, there's some great organizations around the Bay Area. We accept donations with Swarm and Tender that help us to feed our bees, to get all of our gear. We're working towards getting property so we can create a honeybee and plant sanctuary. You can help donate to schools and help the children have the education, because that's our future as well. So that's a really, really helpful tactic.
It's been really fun talking to kids because they come forward with so much information now. An 8-year-old, I'm like, you know more than I do. This is great. Where did you learn this? And they're like, oh, it's a program in my school. I'm like, yeah. So those types of things are things that I'm excited about funding myself, as well as being a part of going and teaching kids, teaching the future and creating a new world.
Another thing you can do is keep bees. If you have any interest in keeping bees, let us know. We have tons of resources. We can help you get started. You don't need a ton of space. You don't need a ton of know-how. The more bees there are around, the better.
And they're wildly adaptable. This is an image of our front of our house. We were lucky enough to be sharing some time with family, and we thought, okay, we'll put work down for the day. We were wrong. The bees decided to swarm and come right into our very own front yard. We couldn't determine whether they were even bees from our colonies at our house. They came and they clustered up on this tree in the front yard, and Mariah's family was a little tentative. We're standing in a cloud of bees like, come on, guys, come over here, this water's fine. And
my 3-year-old nephew was like, Auntie Moonpie's crazy.
So this image kind of illustrates, and we have a video as well, that shows just how natural and docile they are in that swarming quality. It's a common misperception that like, oh no, there's a bee swarm, it's a cloud of bees. They're actually just looking for a new place to live. So we'll go, no suits, just grab any sort of vessel we can and put them in a box to give them a new home, provide that space and provide that nurturing quality for them.
We also, with Swarm and Tender, do live removals, rescues, and relocations of both honeybees and bumblebees. The California native bumblebee has just been put on the endangered species list. And so what we're doing is working closely with different exterminating companies and asking them to funnel us their honeybee and bumblebee calls, and then we'll go and actually do live removals. The image on top is of us doing a removal from a chimney. Honeybees have really been enjoying colonizing chimneys this year, so we're up on a lot of roofs. We have specialized equipment where we can actually suck the bees out with a vacuum without hurting them. There's a padded cage inside, and we funnel the bees in there, cut out all of their comb because it takes 6 parts honey to make 1 part wax, and we want them to keep that hard work. We then rubber band them into frames, put them into boxes, and move them to a place where they can live healthy and happy with a big foraging field close by.
And then we get to use them for education. In that final photograph, Mariah has what's called an observation hive. We like to carry that around, show people if anybody's got any fear, they don't want to be around bees out in nature, they can see them through the glass and actually watch their intricate systems working. Everybody inside, you can take frames from a hive like this, put them in the observation hive, and they just keep working. They just keep going and doing it tirelessly, which is always fun to share.
But it is the video of the image of us right next to that swarm. It's just us without any suits dropping that swarm into a box to illustrate that they're really, really gentle, docile, and kind. The reason that honeybees would ever be aggressive is because they're defending their territory. They're trying to protect their queen. They're trying to protect the larva and the honey. When they're swarming, they don't have a home. They don't have larvae. They're looking for a new place to live. So we can put our bare hand into the middle of a swarm, and they just kind of crawl over our hands like little fairy princesses. Here are some other images of things that we're doing. Again, illustrating education. We love to teach people about bees. If you can't tell, we kind of are excited about honeybees. We like to actually bring groups of children, bring groups like you. We've brought groups at corporate resorts or big luxury resort scenarios into an apiary so we can actually open up that box and show the magic of what's happening inside. In the bottom picture, we actually were able to bring some honeymooners into an apiary so they could harvest fresh honey from a colony and really make that honeymoon full of honey. And again, these two pictures are of some removals that we've done. What we do is the one in the bottom corner is of an eave that was about 35 feet up, and we go and remove the bees, cut out that wax, and then relocate them. So the humans can feel safe and comfortable, and the honeybees have a safe, comfortable place to live.
So what's next in our game plan is we need space to bring these removals. We want to have space where we can just plant all of these flowers. There have been multiple sanctuaries that have been created in the United States as well already that are showing dramatic changes in the loss of overwintering bees. One in particular is boasting a 5% overwintering loss, which is unheard of. And the reason that they're able to say that this is happening is because they plant all organic forage. They're not near a bunch of power lines. They have people tending them that really care and are gentle and are letting the bees kind of rewild their genetics, mixing with each other, all in the same place, those drones getting that job done, and making that genetic stronger and more virile.
Morgan Freeman is another example of, he's kind of an inspiration for what we're trying to do. He just donated, I think, 115 acres of his property in Missouri to be a honeybee sanctuary, and then started to work with bees and is just completely converted and loves honeybees. Probably won't ever act again because he's just got to be with the girls all day, every day. So that's what we're hoping to do. We're looking to find a chunk of land in Northern California where we can bring the removals. At this point in time, we have about 5 apiaries, all at different friends' houses and in different friends' farms, who are kind enough to let us bring lots of honeybees and bumblebees whenever we need to. But we're hoping to create a sanctuary where, like Spencer was saying, create a situation where we can really bring down those losses over winter, where we can also create a sanctuary that people are welcome to come and we can offer more education. We can plant those medicinal herbs and share this passion and information. And so we have a little bit of time for questions and answers. We wanted to leave a little space in this hour long in case we didn't cover anything or if you guys have clarifying questions. And we're also happy to stay long after and chat you up about bees. Any questions?
So during I think it's the worker bees, you said they go on or forage bees, whatever, they go on a flight to 500 flowers at a time. Are they normally the same type of flower, or how do they pollinate the right types of flowers with the pollen?
That's a great question. Generally, if there are a number of the same plant in the area, so if you imagine a field of mustard, they'll be flying to whatever flowers are around. So often, yes, if they fly from one flower to the next and another flower, and they say go to 5 different species, that little pollen, it goes without saying that a number of those pollen flecks will drop from that bee into the pistil, which is the female part of the flower. And so if there are 5 droplets of pollen that go in, if one of them is from the same type of flower, it will still pollinate that flower.
But they're opportunists mostly. They're just looking for the closest, best thing, the most tasty treat. Non-discriminatory is another way to put it.
Any other questions? Yeah.
So honey is like food storage for the bees, but I guess I'm wondering, when we harvest honey, does that take away from their food stores? And then how do they have food stores left? And then a follow-up question is, if bees now just make more honey, like you said that we genetically select for that, then absent harvesting honey, do they just make less? Or
That's a great question. So we try to, as a kindness, only harvest about 20% of the possible honey that we could harvest from bees. They're making it for themselves, but they're also one of the only creatures, aside from human beings, that have more food than they could ever possibly need. That judgment is obviously a human judgment. Sometimes they're planning 5 years ahead. They're knowing that something called a dearth will be coming through, where there's less flowers, or like we were experiencing in a drought. Less water means less nectar, means less honey, less flowers, less food for the bees. Some large big ag beekeeping will take everything and they'll supplement with sugar syrup. That sugar syrup's kind of like taking your organic meal and giving McDonald's. It's not the greatest. It is sustenance. They can live on it. But it kind of depends on the beekeeper, depends on the situation. The bees that are specifically used just for honey harvest are often left with nearly nothing, which is another problem.
And the second part of that question is, if we have genetically chosen bees that are making more and more honey, they'll just continue to do it. As long as there's forage and nectar, they'll continue, and people can put boxes and boxes. I think the tallest we've had is maybe 6 boxes on a very productive hive. And we give what's called multiple brood chambers. And so people who are harvesting honey put an excluder, a queen excluder, because if the queen can get somewhere, there will be eggs, not just honey. So we put a grate on top and the workers can go through. And so we know anything above that queen excluder will just be honey. We often put 2, sometimes 3 brood chambers to make sure there's a huge population so those bees can survive. And then after that, if they are prolific enough to make extra honey, we'll harvest a little bit. But we're not in the business of honey. We're in the business of rescue and relocation and education. We're really trying to help these girls have a comeback. Honey's delicious. It's a great talking point. We can bring it to different markets. We can share it with people and then kind of scoop them in so we can teach them about honeybees.
Hey, how long might a single colony stay in the same hive?
That's a good question.
Indefinitely. If the conditions are great, if a queen, as we said, a queen lives 3 to 5 years, if that queen dies, they'll make a new queen. And so any fertilized egg can become a queen if fed royal jelly throughout the duration. So an egg is an egg for 3 days, as Spencer has mentioned. If they, in those first 3 days, understand that they're queenless, they'll feed that egg between 2 and a dozen generally to make sure that they have a viable queen. And then they can just continue to live in a place. So there's a building that's had the same colony with multiple queens for more than 25 years, close to where we live. And the people just understand that they're doing good work and it's kind of in the back of the shop, so it doesn't really matter, so they let them stay.
Do they start producing new queens while the existing queen is still alive sometimes, just when she's like getting older, or is it not until after she's died?
That's a great question. They do produce queens while the queen is still alive. In the case of an aging queen, they'll notice that her laying pattern of eggs starts to get spotty. We call it spotty brood. If a healthy virile queen will be laying this kind of perfect disc of brood or eggs, and then as she gets older, she starts to misfire. Sometimes the bees will see that as an opportunity to make a newer, healthier queen. They'll make between 12-ish queens, and those will hatch. They'll actually battle royale sometimes inside the hive because they don't have a barbed stinger. So they'll sting each other or go and sting through the cells, one queen wanting to reign supreme. Or sometimes multiple swarms will happen from that single hive. But always there will be one queen inside.
Yeah, and that is sort of where the gentle communication gets a little bit more Game of Thrones, if you will. A queen will hatch and they will battle. The first queen to hatch, if she's replacing a sick or dying queen, she will actually go and kill the other queen. And then she'll go around and sting all of the other queen cells that aren't yet hatched so she doesn't have any competition for the throne.
But there's at least always one queen, right?
Yes.
So in addition to wanting to reboost the bee population and to help out and whatnot, we've noticed a spike here at Google and also in the Bay Area, a spike in urban beekeeping. Yes. What do you find is the major difference between the two as opposed to having it on land or a rooftop?
I love urban beekeeping. I think it's amazing. Spencer lived in New York and worked with people who were keeping bees on rooftops there. Urban beekeeping often works really well because we're not worried about a dearth in flowers because people keep their yards with flowers all the time. Because we landscape and have lovely, beautiful pollen-producing flowers, urban beekeeping ends up working really well. And it's also a great education talking point.
And it's kind of going in parallel with people doing rooftop gardening, like here, or just having planter boxes out of their skyrise, just something that is available. And bees are not afraid of going up, and they're not afraid of going far distances. So it's great. It's kind of creating the ecosystem that was once here, that was paved over, and then now that it's evolved into a city, we can re-illustrate the value of having bees and plants side by side with the style of living that we've chosen.
We're pro-bees pretty much anywhere they can be.
Yeah, put them all.
Well, we want to thank you guys so much again for being here and really appreciate your time. Thank you very much.
Thank you all.